So this is an introduction to three-dimensional geometry for class 11 for the ISC and CBSE syllabus. I am Suman Matthews and I have been teaching maths to classes 11 and 12 over a decade, and I'm trying to simplify this topic because it is not an easy topic, and by watching this video it will prepare you for doing three-dimensional geometry for class 12. So that is the takeaway of this video. You will be well prepared to handle class 12 three-dimensional geometry. Here we will be talking about coordinate planes, coordinate axis and distance formula. Now we have three planes, xy plane, yz plane and xz plane. In the xy plane z is 0, in the yz plane x is 0, in the xz plane y is 0. So coordinates of the foot of the perpendicular from any point on the x-axis is x0, 0. Coordinates of the foot of the perpendicular on the y-axis is 0, y0. And on the z-axis, x and y are 0. So coordinates of the foot of the perpendicular on the z-axis is 0, 0, z. Write the coordinates of the foot of the perpendicular from 3, -2, 5 on the x-axis, y-axis and z-axis. So on the x-axis only x is non-zero. So coordinates of the foot of the perpendicular from 3, -2, 5 on the x-axis is 3, 0, 0. On the y-axis x and z are 0. So it is 0, -2, 0. On the z-axis x and y are 0. So it is 0, 0, 5. And coordinates of the foot of the perpendicular from 3, -4, 5 on the xy plane. On the xy plane z is 0, so it is 3, -4, 0. On the yz plane x is 0, so it is 0, -4, 5. And on the xz plane y is 0, so it is 3, 0, 5. Now reflection relative to the xy plane. If we reflect a point here on the xy plane, the z coordinate sign changes. If we reflect relative to the xz plane, the y coordinate sign changes. And if we reflect relative to the yz plane, the x coordinate sign changes. And when you reflect x, y, z in the xy plane, the z coordinate sign changes. So it becomes xy minus z. When you reflect xyz in the yz plane, the x coordinate sign changes. So it becomes minus xyz. And when you reflect it in the xz plane, the y coordinate sign changes. So it becomes x minus yz. Find the image of -3, 4, 7 in the yz plane. Here the x coordinate sign changes. So it is 3, 4, 7. Find the image of -7, 2, -1 in the zx plane. The y coordinate sign changes, so it becomes -7, -2, -1. We have the distance formula, which says the distance between 2 points x1, y1, z1 and x2, y2, z2 is square root of x1 minus x2 the whole squared plus y1 minus y2 the whole squared plus z1 minus z2 the whole squared. So find the distance from the origin to 6, 6, 7. If I use the distance formula, it is square root of 0 minus 6 the whole squared plus 0 minus 6 the whole squared plus 0 minus 7 the whole squared, which is 11 units. Next question. Find the distance between 2, 3, 5 and 4, 3, 1. So if you use the distance formula, you get root of 2 minus 4 the whole squared plus 3 minus 3 the whole squared plus 5 minus 1 the whole squared, that is root 20, which is 2 root 5 units. Find C so that the distance between 7, 1 minus 3 and 4, 5, C is 13 units. So using distance formula, you get root of 7 minus 4 the whole squared plus 1 minus 5 the whole squared plus minus 3 minus c the whole squared is 13. When you have a square root, you square both sides. So you get 9 plus 16, this is a plus b the whole squared. 9 plus 6c plus c squared is 169. You get a quadratic. Solving it, you get c squared plus 6c minus 135 is 0, or c is minus 15 and 9. Find the distance between -3, 4, -6 and its image in the xy plane. Image of -3, 4, -6 in the xy plane will be xy plane, the z coordinate changes. So it is -3, 4, 6. And distance will be root of -3 plus 3 the whole squared plus 4 minus 4 the whole squared plus minus 6 the whole squared, that is 12 units. Find the distance of the point 342 from the x-axis. X-axis, first find the perpendicular, foot of the perpendicular from 342 on the x-axis. On the x-axis y and z coordinate is 0. So it is 300. And then use the distance formula and find the distance between 342 and 300, which will be root of 16 plus 4, which is root 20, which is 2 root 5. Find a point on the x-axis which are at a distance of 5 root 2 units from 2 minus 3, 5. So let the point be x 0, 0. So I get root of x minus 2 the whole squared plus 0 minus 3 the whole squared plus 0 minus 5 the whole squared. It is a distance of 5 root 2 units from 2, 3, 5. And you will get x minus 2 the whole squared plus 9 plus 25 is 50. So you get a quadratic x squared minus 4x minus 12 equal to 0. So your roots are 6 and minus 2. So your points are 6, 0, 0 and minus 2, 0, 0. Find the point on the z-axis which is equidistant from 1, 2, 3 and 3, 2, minus 1. Any point on the z-axis is 0, 0, z. It is equidistant from 1, 5, 7 and 5, 1, minus 4. So I have 0 minus 1 the whole squared plus 0 minus 5 the whole squared plus z minus 7 the whole squared equal to 0 minus 5 the whole squared plus 0 minus 1 the whole squared plus z plus 4 the whole squared. So simplifying you get z minus 7 the whole squared is z plus 4 the whole squared. So z is 3 by 2 and your point is 0, 0, 3 by 2. Use distance formula to show that the points A 1 minus 1 3, B 2 minus 4 5, C 5 minus 13 11 are collinear. So if you calculate AB, you get it as root 14. Calculate BC using distance formula, you get 3 root 14. Calculate AC using distance formula, you get 4 root 14. AB plus BC is AC implies ABC are collinear. So thank you, and take a pen and paper and practice every line along with me, and stay tuned for my next video, that is part 2 of 3D geometry for class 11.